Here we will see working of Kestrel server. Applications are often written to respond human actions. With event-driven programming, there is a loop that listens for events and then it triggers a callback function. To reduce the number of system calls, all other work is executed in managed code on standard .NET worker threads. Kestrel provides an event loop and callback-based notification of input-output. libuv manages the gathering and monitoring of events from operating system. The user can register callbacks as an event occurs. So Kestrel uses libuv for input-output work and supports running multiple event loops. Since it is a lightweight, Kestrel does not allow user to do SSL termination, URL rewriters or gzip compression. But the same lightweight design can make other web servers to look slow by comparison. It is a 6 times faster than Node.js for static and plain text operations. Workflow of Kestrel server is: first, client sends the request through browser, then Kestrel server listens for HTTP requests and creates the HTTP context. Then requests are passed to the middleware pipeline. After that, controllers or endpoints generate the response and then the response travels back through middleware and sent to the clients by Kestrel. Kestrel supports HTTP/1.1, HTTP/2, HTTP/3 and asynchronous request processing. After accepting the connection, Kestrel listens on specified ports for incoming HTTP requests using a non-blocking asynchronous input-output model. It depends on low-level system APIs like IOCP on Windows or EPOL on Linux to manage network events efficiently without assigning a dedicated thread to each connection initially. Then Kestrel listens on configured TCP port and accepts incoming connections via asynchronous sockets. It processes requests once a connection is accepted. Then it creates an HTTP context object to store request details and passes the request to ASP.NET Core middleware pipeline. A thread from the .NET thread pool is pulled to execute the handler code, which is typically asynchronous. By default, Kestrel supports 5000 for HTTP and 5001 for HTTPS. When a request arrives for products, it will open https:/localhost 5001/products. Then it creates HTTP context object which contains request information, response object, user information and session data. It creates an HTTP context object to hold request details but does not assign a dedicated thread immediately. Then it sends the request to middleware pipeline. When the request enters to middleware chain, the server parses raw bytes into structured HTTP request which includes headers, methods and bodies. It performs initial processing such as URL routing and header validation and passes the request to middleware chain. Middleware chain contains exception middleware which catches the unhandled exceptions thrown by latter middleware. Then static file middleware. It sends static assets like HTML, CSS, JavaScript and images directly to client which bypass the main application logic to improve performance. It also contains authentication and authorization which validates if the user is logged in and permitted to access the resources. And controller which serves as the final destination for a specific route which executes the core business logic and sends the final response to the client. At step 5, endpoint is executed. Here configuration is handled via Kestrel server options using the listen family of methods or by defining endpoints in appsetting.json. Each endpoint specifies a URL and optional settings like protocols and certificates for HTTPS and response travel. After this, the response travels back to the client. After input-output completion, the operating system sends a notification and triggers back a callback that completes the task. The continuation node is then scheduled on an available thread to build the response which is sent back to the client via preserved HTTP context.